Hi friends, welcome to my YouTube channel. So today we will discuss some questions on empirical formula which would be important for your GCSE and also A level. First, they ask few questions regarding empirical formula in A level too. Okay, so first of all, what is an empirical formula? The empirical formula of a compound gives the simplest ratio of the number of different atoms present. So it is the simplest ratio of the number of atoms present in a compound. So how to find the empirical formula? There is a very easy way to find it. You will be given with the mass. Okay. So mass of the atom you will be given. And you have to find, the second step is you have to find the moles. So what is the moles? What is the formula of moles? Mass divided by molecular mass. Molecular mass. And the third step is take the simplest ratio. Take the simplest ratio. So these are the three easy steps. Just find the moles and take the simplest ratio of the moles. That's it. Okay, let us do it by some questions. So see, so here what they say, they are saying find the empirical formula of chromium oxide containing 68.4% of chromium and mass of chromium and oxygen are given to you. Okay, so first of all, this is the percentage given, correct? We will assume this to be like total to be 100% because it is a percentage. So the mass of chromium is 68.4 grams. Percentage, you can convert it into mass. Next, you have mass of oxygen. So what would be the mass of oxygen? 68.4, no, 100 minus 68.4. This will come out to be 31.6 grams. So now you have the mass of chromium and mass of oxygen. Now what you need to do? You need to find the moles. So let us find the moles. Moles of chromium, 68.4 divided by 52, which will come out to be 1.32. And moles of oxygen, what is the mass of oxygen given? 16. So 31.6 divided by 16 equals to 1.98. Now let us take the mole ratio. Mole ratio. Chromium is to oxygen. So what is, how many moles of oxygen, chromium you have? 1.32 and moles of oxygen 1.98. Correct? So which is the smaller number? 1.32 is the smaller number. Divide the entire equation by 1.32. So 1.32, 1.32. You will get 1:1.5. So see, the amount of atoms cannot be in the fractional number. It needs to be a whole number. Now, how to convert this equation into a whole number? So what I'll do is, I'll do this. Correct? 15 by 10. 1.5 means 15 by 10. So next thing, what to do? Just take 10 to the other side. So 10:15, which would be converted into the simplest ratio, 2 and 3. Correct? Cut it on the 5 table, table of 5, and you will get 2:3. So chromium is 2 and oxygen is 3. So this is the required empirical formula. Empirical formula. So I did nothing. I just found the moles and then I took the ratio. Fine. So this is the first type of question you can get from like finding from the percentage. Now let us discuss the second type of questions. In the second type of questions, you will be given with some equations. So you have to play with the equation. So what they are saying, the empirical formula of hydrocarbon, if 4.4 gram of carbon dioxide and 3.6 gram of H2O are formed when it is burnt in excess of oxygen. Okay, So hydrocarbon. So we have to find the empirical formula of the hydrocarbon. So first of all, find the mass. So mass of oxygen would be, okay, no, mass of carbon dioxide would be calculated. Pause the video and calculate the mass of carbon dioxide, 44. And then mass of H2O would be 18, correct? Gram per mole, gram per mole. Okay, next, let us find the, okay, first of all, let us assume the hydrocarbon to be CXHY. So what would be the equation? So equation would be CXHY plus O2 give rise to CO2 plus water. So how much? For 4.4 gram of CO2 and water is 3.6 gram. So we have to find this hydrocarbon. So if we can find the number of carbons and number of hydrogens, we will be able to calculate the hydrocarbon also, because this needs to be a balanced chemical equation. So let us find the moles of carbon dioxide. Moles of carbon dioxide, 4.4 divided by 44, it would be 0.1 mole. And moles of water, it would be 3.6 divided by 18 equals to 0.2 moles. So now you have moles of carbon dioxide and water. So 1 mole of carbon dioxide has how many carbons? 1 mole of CO2 has 1 carbon, 1 mole of carbon, correct? Because in the formula it is CO2. So 1 mole contains 1 mole of carbon and 2 mole of oxygen. And now 0.1 mole of carbon dioxide will have 0.1 mole of carbon, correct? So this is equation 1. So now 1 mole of water. 1 mole of water has how many hydrogens? 2 mole of hydrogen. Correct? We have 0.2 mole. So 0.2 mole of water will have how many hydrogens? 0.2 into 2. That would be 0.4. So 0.4 mole of hydrogen. This is the number 2. So we have, so we have 0.1 mole of carbon and 0.4 mole of hydrogen. So let us take the ratio. Ratio of carbon is to hydrogen. 0.1 is to 0.4. So divide the equation by 0.1, which is the smaller number. So you will get carbon ratio hydrogen is 1:4. So the formula would be CH4. So this is the required empirical formula. Okay. Fine. Just find the moles and do the question. I hope this is clear. Now we have third type of questions. So in the third type of question, the volume would be given. Like see this question. 50 centimeter cube of carbon dioxide are formed when 50 centimeter cube of hydrocarbon in the gaseous form is burned with exactly 250 centimeter cube of oxygen. Okay. Actually, here is some problem. So this is 150 centimeter cube of carbon dioxide. Okay. So now let us first write the equation again. So empirical, we have to find the empirical formula of the hydrocarbon. So CXHY plus O2 give rise to CO2 plus water. So how much hydrocarbon we have? We have check for the hydrocarbon. We have 50 centimeter cube of the hydrocarbon. So I'll write 50 centimeter cube and oxygen, it is burnt with 250. So 250 centimeter cube, and it leads to the formation of 150 centimeter cube of carbon dioxide, and water we don't know. Okay. So now see, so we have to again find the moles first. So how we will calculate the moles? So now the volume is given to you. How to calculate the moles from the volume? What we do? We divide it by, so this is 50 centimeter cube, means it is 50 ml. Centimeter cube means ml. So how to find the moles now? Think. Okay. So finding the moles when the volume is given in ml, we divide it by 24,000. So let us find the moles now. So 24,000 divide by 24,000 and divide by 24,000. So how much you will get? This will be 0.002. For the oxygen, it would be 0.0104. And for the carbon dioxide, it would be 0.00625. And this we have to find. Okay, now we have moles. I told you to take the simplest ratio now. So let us take the simplest ratio, dividing it by the smallest number, 002 and 0.002. So it will come out to be 1, 5.2 and 3.1. Take the simplest one, 5, 1, 5 and 3. Correct? So now see. So now you have 3 moles of carbon dioxide and 1 mole of hydrocarbon. So what would be the balanced equation? Like CX HY plus 5 O2 give rise to 3 CO2 plus this much of the hydrocarbon. Okay. So we have to find here the moles of hydrocarbon, this much moles of the water. We have to find the moles of water. That is important. Then only we will be able to calculate the amount of hydrogen present. Otherwise, you won't be able to tell how much hydrogen is present. Now see how I can find the moles of water. So see, how many oxygens are there on the left-hand side, on the reactant side? Oxygens on the reactant side. How many are there? 5 twos are 10 oxygens, correct? So, since this equation needs to be balanced, how many oxygens should be on the product side? 10 oxygen, expected oxygens on the product side should be 10. But there are how many? 3 twos are 6. 6 oxygens are here. We are left with 4 more oxygens. So probably here would be a 4, then only 4 ones are 4 oxygens will be there and total of 10 would be there. So what would be now the exact balanced equation? The exact balanced equation would be CX 1 plus 5 O2 give rise to 3 CO2 plus 4 H2O. Correct? So find the moles of carbon and hydrogen. Now it is easy. It is similar to the previous question. How many moles of carbon would be there? Moles of carbon, 3. Moles of hydrogen, 4 twos are 8. So empirical formula would be C3H8. So this is the answer, required empirical formula. So this is an important question. Just go through it once more. I hope it is clear. Now let us move to the next question. Okay. So the next question is for you. So what it says, calcium dihydrogen phosphate can be represented by this formula. So what is written here? I'll just highlight it. This is calcium H2PO4 and X. So you have to find the X value. So this X you have to find. So this question is for you. Do this question and send it to the mail given in the description box. We will check it and will revert back. So you can comment the answer also. So the x value is 2. Just find it. So I'll tell you the answer. X value equals to 2. Find the answer. Okay, so this is the answer. Find the method to do this. And also one more important information, our institute also provide one-to-one live sessions in chemistry. So if you want any, you can just mail us. Okay, hope you liked the video. If you liked the video, do share and subscribe it. Okay, bye-bye.